Assalamualaikum and very good morning to all. Today our group going to present a case study about total knee implant. So let's get started with our first presenter.
Greeting to our Dr. Zaleha. My name is Noel Tan from Group 3. Today we will present about the case study, which the title is Knee Implant. My part will explain more or less the meaning of the component that knee implant using. Thing we have to know that for natural knee joint have three compartments, which is the internal side of the knee, the external side of the knee, and under the kneecap. One of the common surgical medical for knee using is total knee replacement, which is involve replacement articular surface such as femoral condylis, tibial plateau, and polyethylene plastic. Total knee replacement is one of orthopedic surgery. During TKR, each of compartment of knee are being replaced. Therefore, there are four artificial components which compose TKR, which is femoral component, plastic spacer, patellar component, and last, a tibial component. Artificial replacement component usually made of strong metal, ceramic, or plastic. So TKR will have part made of material such as metal. Usually, total knee replacement made from cobalt chromium alloy because the material have durable, biocompatible, and corrode not respond with the body. That's all from me. The other part will continue to my group member. Thank you.
Assalamualaikum and very good morning, Dr. Zaliha. My name is Nashamila Aizat binti Baharudin as a second presenter. Today, my part will explain about material selection strategy. Before we manufacture the knee implant, there are 4 steps need to be taken to selecting the best material for the knee implant. So the first step is translation of a design requirement. This process contains of 40 with a function, constraint, objective, and material variable. For the knee implant, the function is a displacement of a knee joint. The constraint needs to be biocompatibility, adequate strength, high corrosion resistance, high ductility, elastic modulus, and high wear resistance. While for objective, need to be maximize the compressive force and minimize the density. And lastly, material variable is choice of material and choice of manufacturing process. After then doing the translation, we create a graph from the constraint focus with material index to find the well-suited material for the knee implant. There are 5 materials be identified to be the best material, which is polyethylene, zirconia, cobalt chromium, stainless steel, and titanium. The next step is screening. Screening is a process to make the comparison before eliminate the unsuitable material. From the table here is a material property will based on the data that have been retrieved from the CES software. Before eliminating the material, we screen by using the constraint that we have set in the design requirement by using the graph from the CES software, which density against the Young modulus. This process focuses on the material index to find the well-suited material for the knee implant. This process to achieve the objective and the constraint of the design requirement for the knee implant. So after we make the screening, we found that polyethylene need to be eliminated because of the compressive strength is lowest compared to the other material, and zirconia eliminated due to the price is too expensive. So the suitable material is cobalt chromium, stainless steel, and titanium. For the ranking step is a step that need to choose the best material from this three material, which we rank the candidate from 1 is the worst to the 3 is the best. As you can see from the table, we can see that cobalt chromium has a higher total properties. And the last one is documentation. Based on the table from the slide before, the best material as a design requirement for the knee implant is a cobalt chromium. This cobalt chromium fulfill the design requirement for the knee implant since the objective material selection is maximize the compressive force and density. And this material is tough, durable, and will not broken inside the body chromium because of higher compressive strength and have a good wear resistance. Although cobalt chromium has a higher density from the others, but the cobalt chromium is comparable to the bone of weight, and the constant of also be fulfilled in terms of biocompatibility and corrosion resistance. And however, cobalt chromium is commonly used for the femoral implant since the very sturdy and femoral implant has a lot of traction against a plastic spacer during the movement.
Greeting everyone, my name is Dalgus Dipa Ajang and I will present about the manufacturing process for knee implant. In flowchart, it start with design, raw material, and then going to melting machine for melt, and then going to investment casting, and then bring test for perfectly shaped, then going to rough machining, and then bring test for no defect, and then going test again for precision, and then going to polishing, and then for the last test, and then going for the customer for knee implant surgery. In melting process, in test for perfectly shaped, no defect and precision, and last test, if the product not meet or pass the stage, it's going to back again to the melting machine or being redesigned again. This is the translation of design requirement for shaping process. Function is to fabricate the knee replacement. Constraint is it is a primary shaping process, able to produce accurate size, can be used with the chosen material, able to produce 3D shape. Objective is to minimize the tolerance. Variable is choice of shaping process that we use. In screening, requirement is solid 3D shape must be produced from the process. The process is also chosen to be a primary shaping process. First stage of shaping is investment casting, and then second stage is a machining process. Then ranking is done. Two processes is selected, that is investment casting and machining process. Documentation for investment casting, it can manufacture complex shape for sensitive application with great dimensional accuracy. It can improve surface texture and has tight tolerance, and casting are available in variety of size and wall thickness. Secondly, in machining process, which is grinding and milling, it can obtain the desired shape and improve surface finish. Joining process translation. Function is to join part of fabricated knee implant. Constraint, it is a primary joining process, able to tightly join the part. Objective is to maximize movement. Variable is choice of joining process. Hinge or pin used if the patient collateral ligament insufficient, severus or deformity with relevance of tissue release. With help of the pin or hinge, it allows to preserve correct reflection, extension motion, and working of the patient. Finishing process translation. Function is to treat the surface of the knee implant. Constraint, it is a primary finishing process, able to smooth the rough surface and cut any excess material. Objective is to maximize smoothness, and variable is choice of finishing process selected. Polishing process is selected. Polishing process is a finishing process that apply free abrasive with comfortable pad or soft cloth to form shiny and smooth surface. Function of polishing process for knee implant is to make sure optimum practicality and then for the lifespan of joint replacement system. The bearing surface of the prosthesis square measure needed to be polished to nanometer scale surface texture with micrometer scale type tolerance.
Okay, my name is Anur Iman, and now I'm going to explain about the effect parameter on the performance of the products. Okay, let's get started. Okay, for the effect parameter, there is two parameters required, which is material properties and process parameter. Okay, now for the material property, as we all know, the knee is where we have the highest impact on our body due to our weight. So the fracture toughness, compressive strength, impact resistance are the most important key for the material. Meanwhile, the weight also important to keep balance of the body, and the wear resistance important so that the user can use in a long terms. Okay, now for the process parameter, as we all know, the shape must be able to produce a 3D shape solid, and the production of the product must be able to control based on the customer demand. Meanwhile, the material must be compatible to the process. Then the surface smoothness of the product helps the joint have less friction, and then the tolerance is a major part of the process because it need to be measured by the actual size of the patient knee. And last but not least, the inspection, where the inspect will be maintained and the quality of the knee is implanted. And then that's all for me. Thank you.
In this section, I will explain to you about testing and quality control for total knee replacement, also known as knee implant. For total knee replacement, there are consisting two major components. The first one is femur component. The second one is tibial base plate. For femur component, it is curved shape that groove around kneecap so that our knee can move up and down smoothly while we are bending our knees. For tibial base plate, it is a flat platform that will act as a cushion to our femur component. It is also help femur component align to our knee straight. This is an example for total knee replacement testing. For femoral implants, they are dynamically tested during opening and closing condition to stimulate stresses due to poor bone condition. This is called fatigue testing. This testing is to evaluate the resistance to failure after loading against femoral component. The contact area and stress distribution are characterized at multiple flexion angle and loads. For tibial base plate, fatigue testing is performed by fixating 1.5 of the tibial base plate and applying a constant amplitude load to the unsupported half of the base plate. This testing is to determine the endurance properties of knee tibial tray. This is an example for inspection type. Specification for surface finish of knee replacement. Endurance properties of tibial trays. Fatigue testing of total knee replacement femoral component. Total knee replacement loading profiles. Tibial insert endurance and performance under high flexion. Guide for evaluation of modular hip and knee implant.
Hi, my name is Shasha Shahinda binti Rosli. In this part, I will explain about the type of defect in knee implant and countermeasure to avoid defect. Type of defect, they have two types of defect, which aseptic loosening and fractures of femoral component. The firstly is a aseptic loosening. Knee implant loosening is mainly caused by the weakness of the prosthesis bone interface. The three major causes for aseptic loosening of total knee implant including 1. Excessive wear between articular surface. Second, stress shielding of the bone by prosthesis, and third, micromotion of the component. All these causes occur due to the increased stress or load imposed on the femoral component during deep flexion activity such as cycling activity. So it could lead to loosening the knee implant. The secondly is fractures of femoral component. Fractures of femoral component is one type of defect in the implant. The risk factor of fractures is obesity due to overload impact on the femoral component. This is because the stress fractures of the femoral component have predominantly affected the medial condyle as shown in figure 1. Figure 1 shows the breakage of the medial condyle of the femoral component. Other factors that involve in fractures of total knee replacement include implant loosening caused by an even cement crimping of the femoral component to the bone, excessive loading stress due to heavy labor, higher body mass index, and a higher athletic activity. In figure 2 shows the example fractures of the femoral component. The countermeasure to avoid defect is the prosthesis or knee implant can be designed to reduce the effect of loosening, including wear, micromotion, and the effect of shielding stress. Countermeasure to reduce wear is add contact bearing surface, where resistant material should be used while in areas close to bone tissue. Material with less elastic modulus are recommended to reduce the effect of shielding stress. And finally, at direct contact areas of the prosthesis and bone, a bioactive material is suggested to reduce the micromotion. The femoral component in total knee replacement requires a biomaterial with properties to avoid the aseptic loosening problem and fractures of femoral. These properties include high strength, low elastic modulus, good ductility, high corrosion, wear resistant, and biocompatibility. Inability of knee implant material to fulfill any one of these requirements or a combination leads to failure of knee implants. That's all from me. Thank you.
In a conclusion, there are several processes in making the total knee replacement. The first step is select the best material in material selection strategy. So, in the material selection strategy, the best choice for material is cobalt chromium because it has high compressive strength, wear resistant, and high corrosive resistance. The use of flowchart is just the guideline for the process making production of the knee implant. Then goes to manufacturing process, which is the suitable process for the metal. So we choose the appropriate process making the product is investment casting and raw machining due to the low manufacturing price. In order to make the improvement of knee implant product, it must know to analyze and determine the effect parameter, the type defect, and countermeasure. That's all from us. Hoping you all understand what we are trying to reaching from this case study about the knee plan. Thank you.